Hi everyone, and we are live at the next session. My name is Pavel Averin, and I'm the operation director at Netguru, and I have the amazing guest with me, Angelo Dalli, chief data scientist from Umnai. And Angelo, let's start with your introduction. Please tell us about yourself. What do you do? What Umnai does? We are all here to know more.
Excellent. Hi, welcome. Thank you for having me here. It's exciting. So I have been applying AI to different industries, different problems for over 24 years now. So I've been in AI for quite a long time. Did my first
Oh my
neural
God,
network in
that's so
1996.
impressive.
Created, for example, some of the initial solutions in bioinformatics when applying AI to DNA sequencing. Did also stuff when it comes to license plate recognition, traffic management, vehicle traffic management on the streets, and also when it comes to recommendation systems. How do you recommend, what stuff for people to buy, this kind of things. So many early uses of AI. And lately, my focus has been on building AI for high-stakes applications that actually enables you to use AI when you actually really need it.
Amazing. So it seems like you've done it all. So that's interesting. So today we'll talk about these exact cases. Reasoning, high stakes decision making. So why do you think it's actually system one and system two thinking? It's not like the new concept like we know in people. Like system one is when we are react to the questions immediately and so on, and system two is when we are actually thinking about the problem, take some time to react and to reflect on it. Do you think those concepts are applying to AI? And is it something similar what we will see in the future when we talk about AI and AI applications?
Yes, in fact, this is something that I think as we have realized that while the current systems that we have in AI, first with deep learning and now with LLMs, are absolutely wonderful, there are certain limitations to them that are becoming more apparent, like as in the previous speakers were saying, hallucination, for example, whether you can rely on what the AI is coming up with, and the reasoning. How do you actually get from a goal to a plan of actions and actually execute it, and then get feedback on whether that plan has been executed well or not? So the system one, system two thinking that you described have both their uses. One, if you need to do quick reactions, say you're controlling a car, you do need to take quick reactions because, if it takes you a second,
Exactly.
you're already, like halfway to crashing. However, if I need to plan something and I do have the time kind of think it through, then the system two is kind of the slow thinking, the logic, the reasoning is much more superior in those situations. So effectively, the way I describe this, that the system one corresponds to the neural networks, which can react very fast, very quickly. You can get the pattern matching. It is unrivaled speed. However, when it comes to the reasoning part, this is when, the symbolic logic, the symbolic reasoning comes into its own world of its own, because this is when you get things like logical thinking things through, seeing, okay, A follows B follows C. And this is where I think current AI systems fall a little bit short.
Uh, do you have the answer how to make it better if the current systems are falling short?
Of course. Yes. So basically what we've been working on, and I've been spending now the last 5 years and 52 inventions later, actually has been on a system that is called Neuro-symbolic AI. So basically it combines neural networks together with symbolic logic. So you get basically the best of both worlds. So imagine you're trying to solve a problem, whatever problem it is that you give it, you prompt it or you give it some problem. The neural network initially will find you roughly where the solution may lie. Then use reasoning to think it through, to refine that potential solution. And this is how also you remove hallucination, the problem of hallucination, because if you understand how the world really works, how things are actually working, how they're following each other, basically, the cause and effect, then you know with certainty that whatever plan you're going to create is plausible, is grounded in reality. It is not something that has been made up or that sounds good, but when you actually think it through, you realize, oh, okay, this doesn't actually make sense in real life. So this is, I think, this combination, which is called neuro-symbolic AI, I feel is the foundation for the future of AI. So I think we're actually going to see slow replacement of the current LLM-based architecture. I know there has been a lot of money being put in, a lot of investment put into it, but I think this is actually going to be mostly replaced by systems that think and reason. We are already seeing this little push towards systems that reason at runtime, but again, the reasoning architecture behind, like models like O3 and all these models, DeepSeek, R1, they're still not based on sound logical principles. And this is the main problem, basically, of it, that you cannot rely on those decision-making processes.
Okay, and do you think like this new approach, this new architecture approach to building this kind of this system, like will this be applicable for the industries where the reasoning is very, important, like their healthcare, finance, legal? Because like at the moment we can't rely on current AI agent and AI applications for those in this industry. So maybe the question: when do you believe we will see the first new era AI applications for doctors or lawyers?
Yes, I think these applications, for example, in healthcare, any applications I call high stakes or high impact applications, where the cost of taking a wrong decision is going to lead to either a lot of financial cost, or you're going to maybe harm someone. This is like really important, in fact, to have AI that you can understand the decision-making process, that you can also understand exactly how it is coming to the decision, what are the basis of its decision making, how justify the predictions that it's making. And effectively, you need to first understand what is happening. Then after you understand, you also understand what the model has learned, because sometimes the AI may be making decisions based on like alien logic. And also, once you do that, you can then start to control it, because you cannot control something that you do not understand, basically. So this is something that I think you need all this chain to build something that then you can trust. Because once you have something that is transparent, that is controllable, then you can align it with what you wanted to actually do, and then be able to collaborate with it and work with it along like you would with a human being, basically. And this is very important to do. And in those industries that you mentioned, like healthcare, legal, for example, if you're doing, say, control of an oil field in the oil and gas industry, you don't want to have an AI that, you don't actually understand fully, 100%. Let's say you're flying an airplane, and even if you understand it 99.9% of the time, you don't want to be on that plane in the 0.1% of the time. So the need actually to have fully, to have fully controllable and trustworthy AI is actually impeding a lot of interesting applications, useful applications of AI when it comes to these high stakes applications. And I think this is holding back actually the adoption of AI in those industries.
Exactly. But have you, in your rich experience and what you're focusing at the moment, have you already seen some fascinating examples of those kind of applications in the real, like, high impact environment? Like, even one example will help us to understand that, this is closer than further.
Yes. So basically, the applications basically area, there are a lot of things actually where you compare the neuro-symbolic AI systems with current systems, you see a lot of improvement. So in differences, like head-to-head benchmarks that we've done, we see, for example, improvements of over 200% in the improvement in results, in the quality of results. And I attribute this to the fact that when you come to symbolic systems, they generalize better. So if you think about it, what is, for example, like an equation? An equation is like a compressed model of the world. And I like to give, as an example, Einstein's equation of E equals mc squared. If you were to uncompress that, you literally get the whole universe being described with just 5 characters. So there is this immense generalization capability inbuilt. And it is not for, like just by random chance that we as people also have evolved to use symbols to communicate knowledge between ourselves. And I think this is actually very important. I think that by generalizing and learning from fewer examples, you also get better efficiency. And we see that current models are just becoming unsustainable, both to train and to run. And we do need, in fact, better techniques in order to, reduce the cost, to also make them more sustainable. So there is like this whole chain of knock-on effects that are actually useful and, needed, which I think neuro-symbolic AI systems bring to the table.
Interesting. What are their like limitations and risks? Like, where do you think engineering and product teams, which will be working with those kinds of systems, what they need to be careful about?
Yes. Obviously, I think actually that by reducing the amount of data needed, by reducing the amount of computation needed, more advanced AI systems are going to become increasingly accessible to development teams, to engineering teams. At the moment, you do have, like LLMs have done a fantastic job when you think about it at democratizing AI, at making it accessible to even non-programmers. I mean, you just learn how to prompt and you get something that is pretty decent in some situations. However, you cannot do this, you cannot apply them in high impact applications. So the limitations, basically, it's more actually solving the limitations. How do you determine that a program that, for example, was coded by an AI is correct? How do you actually ensure that the information that it gives you is reliable? I think, one of the challenges will be if there is a lot of fake news or fake information in that application domain, how do you actually remove that from the training of the AI so, it doesn't get trained in a wrong way? So there are
Exactly.
lots of these set of challenges that need to be overcome. However, this is more of an opportunity rather than a challenge. I think the opportunities are there on how do you actually use this new technology in order to create new application areas, to do things, to solve things that are very hard to do currently with current techniques, which is like literally writing programs by hand in most of these industries versus actually, benefiting from AI. And it's amazing because, I've been applying AI for like more than 2 decades now. And to see that people are still using this very old school techniques in the most critical of industries, to me is, astonishing in a bad way, really. So this is, I think, what will open up things, like making sure that we benefit from this. Of course, in fact, I see like one of the questions actually also about the dependence, like on if people become overly dependent. I think this is actually a danger, a real danger of becoming too dependent in a mission critical situation on AI. I had a good chat, in fact, with some friends who are surgeons, actually. And I was kind of commenting on how would this kind of AI help them do, like keyhole surgeries,
Yeah,
to do them more efficiently and better. And I was thinking, I thought, okay, what if the electricity were to go off? Like, what would happen if it were to go off in the middle of an operation? And they said, well, we'll have to then open them up and like do the thing, like old school. Unfortunately for the patient, if we cannot just pause. In some cases, we cannot just stop, in the middle. And
exactly.
then I asked, like, okay, when was the last time that you actually did this? And you could see like the puzzle look like, yeah, more than a year ago. And this is like what started me to think, okay, what if kind of people in this critical situations actually start to get rusty at their skills? What if everyone starts becoming so dependent on AI that you lose your skill? And in a mission critical system, you need to react quickly, whether you have the AI or not. So I do think that maybe this could be a danger, that we become too reliant on AI and forget kind of the way how to do it without AI, or at least with less AI assistance.
So we'll need to change our habits a little bit. So at the moment, we often trust the systems, and then like we mostly will trust the systems, but we'll have to, make us repeat some things not to get rusty in some skills. So let's dream about like the next year. For example, what excites you the most, like in this kind of development? Please bring us the picture of the next couple of years, and we will finish
Yes.
with that. Describe us the future.
Yes. I think we're seeing a lot of push towards agentic computing, which is something that I think is very exciting, because the fact that AI can go into the world and actually intervene, create something, execute something, change the world rather than just passively observing it, I think this is absolutely fascinating. It's also horrifying if it's not done in the right way. But let's hope that, like these methods are actually used and it is done in the right way. I think what fascinates me, and I think it's going to become increasingly common, is agents that introspect, agents that can actually not just come up with a solution of the events, that actually come to a fruition, the goal, plan, and action, but also think things through, being able to explain. I am going to do this because of this, this, and that. This is why I think this is a good plan. And you can kind of almost have a conversation with it, especially if it's a plan that is going to lead, potentially to financial ruin or to a lot of success if it goes, either way, to actually be able to double check it, to converse with it, exactly like you would do with a human being. You wouldn't, just go and give a go ahead before someone actually at least presents you with a plan that makes sense. And I think this is how the future of AI is going to look like. I don't think that the current LLM-based techniques are actually going to be in our future. I think some of the techniques that are currently in use, in fact, are very useful. For example, to imagine how things can be, like to simulate the world. I think what we
Yes.
have built is very good for that. But I think when it comes to the execution, to the planning, I think the neuro-symbolic AI techniques are going to be at the forefront of that. So this is how I'm seeing the future, and a future where embodied AI, where AI is actually taking actions, working alongside people, not replacing them, but assisting them in fulfilling their potential, in making everyone more productive. And you know what, maybe making us so productive that we have more fun at the end. So I think there is
Exactly.
also there's gonna be a lot of societal change, but I'll leave that. I think we can talk for a long time about it.
Yeah.
But I think that society is actually going to change, like how society changed during the Renaissance. I think that the current wave of AI is going to lead a lot of changes, hopefully positive.
Amazing. I totally bought your vision for the future. I would like to have the companion agent whom I trust, because I know that this system is actually thinking long term, not only the short term. So, Angela, I hope we will see more of these applications. Thank you for the details. Thank you for the inspiration. And thank you for joining us. Have a good day. We're running out to the next session.
Thank you all.